So today's lesson is illumination control. The illumination control is very important for the visual comfort of the person performing or working to complete the task. So that when the person is doing something, so that illumination is very important. This is also important for the visual comfort. So therefore, the illumination control is dependent on the touch luminance, touch contrast, and the glare control. So there are three things are influencing the illumination control. Regarding the touch luminance, there must be the sufficient light so that required work can be carried out correctly and efficiently. So the low lighting level, when the lighting level is low lighting level can cause eye strains. So if the too high lighting, it can also happen the eye strain and the fatigue can happen. Therefore, we have to control the illumination not to be too low or not to be too high to maintain the visual comfort level. So this is very important for the illumination. So regarding the illumination control, we need to follow the AS1680. So this is for the AS1680 standard is illumination control. So every classroom, they must have the 400 lux and also for any detail work. In this case, up to 3,000 lux will be required. So there are touch contrast. The difference between the luminance or the color that makes the objects are distinguishable. So this is also important because of the illumination should make the object to be distinguishable. So the glare also we need to be controlled. Glare is caused by the brightness of the background or the object in the person's field of vision, which disrupt the person from the visual task. So this is why because the glare the person can be distracted. So in this case, we have to follow the law, inverse square law. The inverse square law means that in light source or the one there is a position at a distance d from its surface given the luminance of 1 by d square lux. So this is the inverse square law. If the surface moves from the source, the luminance will be there 1 by 4d square. If the surface moves 2d from the source, the luminance is 1 by 4d square. Surface moves 3d from the source, the luminance is 1 by 9d square. So this is the illumination control. So that we also have to control the illumination control. They are the basic principle of the lighting. So this is the incandescent light. When the current passing through the conductor make it glow white and hot, it produces a light. So this is the halogen lens. In the meantime, the electrodes are luminous. When the current pass through the conducting the gas producing the ultraviolet radiation, which bombard the phosphorus producing the visible light. So when the current passing through, it will produce a UV radiation. This UV radiation bombard the phosphorus. So that by bombarding the phosphorus, it will produce the visible light. Another kind of the light is a gas discharge light. The same as the luminescence science. Luminescence because of the except that there are no use make of the phosphorus to get the visible light. LED is a light emitting diode, so it is a semiconductor. Semiconductor PN junction under the forward bias the current, so emit the radiation by the electroluminance luminance. So this is the fluorescent light. So this is where the electrical current flow. This is a Q. This is the cathode. Here is a mercury atom dischargeable and the lead in the wire. When the electrical current passing through, the phosphorus always produce the light. So this is the kind of the fluorescent light. So the fluorescent light is the filaments are made of the radiated tungsten, coated with the immiscible material. So this is the cathode. Cathode is a filament made of the radiated tungsten coated with the immiscible material. The cathode produces an electron, which flow through the tungsten gas, ionized gas. Cathode produces the electron, which flow through the ionized gas between the cathode and the tube. The cathode are located at the end of the gas, and the fluorescent lamp is two kind of fluorescent lamp. They can be the hot and the cold cathode. So it takes the time for the function. So the fluorescent lamps are usually producing the 40 to 85 lumen per watt, can be increased to the 100 lumen per watt, operate at the 25 kilohertz. The color depends on the coating phosphor. So the useful light is 7,500 to 8,000 hour of the standard tube. So those are the feature of the fluorescent lamp. So this is the high density digital lens. So they are the this is high density digital lens. So this is the main electrode, RQ, also the argon, mercury, nitrogen phase, fluorescent coating, and this is starting electrode. They are utilizing this mercury vapor, and then they also can be the metal halide and high pressure sodium and low pressure sodium. So this is they emit this large volume the ultraviolet radiation. So typical efficacy is 65 to 75 lumen per watt. The similar principle for the metal halide and the high pressure sodium lead and the cesium lead. So those are kind of this high density digital lead. So this diagram shows the light emitting diode. So this light emitting diode operation is it can be the aluminum, gallium, indium, phosphor alloy. So they are producing a red, orange, and yellow, and iridium, gallium. So they are producing a gray, blue, and a white. So this is the less forward when the forward body given. So the LED forward current will be flowing also with this diagram. So this will be the light emitting diode diagram, the forward and biasing, and this is the producing the light. To reduce the potential barrier, so by providing the forwarding, the potential barrier will reduce the electrical current flow. When the current flow, it produces the light. So to reduce the potential barrier to flow the electron junction body and temperature impact on the LEDs or operation. So this is the junction temperature depending on the ambient temperature, current through, and also amount of the heat sink and also materials around the LED. So this is a high pressure sodium light control circuit. So this is a bolus, this is the ignition, this is ultraviolet. So this is the IGS ignition, and is a lamp, B the bolus, C is a capacitor. So this is the construction of the electrical circuit diagram of the high pressure sodium control circuit. This is a fluorescent lens circuit. It includes the cathode and anode here. This is a bolus switch. So the fluorescent light starter. And this is also the electrodes are auto transformer. We can also provide the auto transformer to get the high discharge line, high voltage. So this is bolus also. So this is a quick start fluorescent light circuit. So here is two fluorescent lights are connected and two bolus and a capacitor supply. So this is a leadless circuit. The function to eliminate the stroboscopic effect. So here is a typical diagram of the electrical conversion main control circuit. The 40 ampere, this is for the individual socket outlet fan, their connection, the diagram. So this is in this case, we also providing the these are three-phase relays we provide. So this is also the location of the three-phase relays flow diagram. And here is a typical diagram for the electrical supply and also the socket outlet provided the load, and this is the connection of the GPU. So this is for this plan of the fluorescent light and the fan and the supply connection. Then we are talking about the electrodes. This is for the Bachelor of Applied Science electrical. Now I'm talking about the electrical trade. Then we are talking about the electrical trade. So this is for the methods of fishing. So there are the method fishing are associated. It can include the saddle, clip, conjure, and also bracket switch. Those are the associated. Also the technique for the fishing through the method. There are also the fishing devices. They can be the coach boat, paper method, and threaded boat, and the wall anchor. So they are fishing devices. Fishing tools we utilize a spanner, screwdriver, rubber, fly, and rimmer. So in this case, we also need to follow the occupational hand safety issue. So when you are drilling, cutting, in this case, you need to use an eye protection. Also, metal firing and noise, they are also need to be aware of. We have to use as a power drill bit, and also we need to control the drill speed. We install the fishing devices and accessories supporting the up to 20 kilograms. So this is a diagram of the saddle. Here is a conduit attached by the saddle, and this is a conduit saddle. Also, we use a screw tool and screwdriver. We use a screw tool and screwdriver to support the conduit. Here is the construction of the cable tree. A cable and there is a bracket, and their cables are running on the tree. They are supported by the bracket. So to support this cable on the wall, so this is the function of the cable tree. They are made of the sheet metal. So the wall bracket or the screw, we have to fit the wall screw to fit the wall. So this is the cable tree. On the cable tree, we use a screw to fit the cable tree on the wall. We tie the cables in the tree. After the cable are running on the tree, we need to tighten the cable on the tree. We have to cut the sheet metal. So in this case, this sheet metal need to be cut. So that we have to cut the sheet metal by using a guillotine machine. After that, we have to use a folding machine to form the shape. After that, we drill the sheet metal tray. We have to drill the sheet metal tray for the fishing. So that we have to install the prism. Also, we mark the holes on the sheet metal and the same on the wall to be drilled. So this is for the armor cables are running on the metal tree, so that these cable holders are attaching holding the cable. So we have to set the appropriate cable tree and the mounting devices to support the cable weight. Those are important aspects. So this is the construction of the cable tree. And also this is the construction of the mounting devices. So the column, this is the column here. We attach the mounting devices to the column. After that, we attach the cable tree. So therefore, to fit the cable tree, firstly we have to attach the mounting devices, and on the mounting devices we attach the cable tree. So we have to technique and the devices to fit the metal. So once the load and the accessory has been chosen, the method of how to fasten the survey will depend on the weight. So depending on the weight of your cable tray, we have to select the appropriate method. So that in this case, we utilizing the lightweight devices. So that when you are using the lightweight devices, if you want to support the thin metal surface or the up to 2 millimeters set screw can be utilized. Also, before you are using, you have to make a pilot hole, and then we have to penetrate the screw. After we have to cut the old thread into the metal. So they are set threads to cut this old thread into the metal. If you want to attach the larger devices. So once the weight starts to increase, there's materials are tightening start to larger. In this case, we have to utilize a coach board. Coach board need to be utilized to hold the larger close to the surface. So we have to use as a hand tool. So this is the diagram of coach board. Hand tools are we have to utilize a screwdriver, open-ended spanner, range spanner, adjustable spanner, and for rubber cans are have to utilize. And for the safety, we have to wear the goggle, earplug, and gloves have to be utilized to protect the brighter noise. Here is a power tool. So in this case, they are hand drill, collar drills. We have to utilize. We have to use up to 12 millimeter chow need to be utilized, and also that we are using the adjustable speed. Here is a postcard drill. In this case, we have to drill the more accurate hole. In this case, we have to use the bit stress drill. So the material is a clamp to the drill for the smoke. So that in this case, we use the waste of material have to be removed. In this case, all the waste material swap need to be properly removed for the safety. So in this case, I'm going to safely remove the waste material. So this is for the this diagram is a typical diagram of the installing your electrical. Here is a fluorescent light. To install a fluorescent light, we have to utilize this diagram. So this diagram, we can see the installation of the fluorescent light in the room. So that this is for your task. You have to provide with the 2 meter and 1 meter metal sheet. So you need to cut the sheet from the given tray and fix onto the wall. So this is for this how to fix the electrical circuit diagram and also switch on the wall. So the wall is made of the brick. So in this case, we have to need to install the cable tray to carry the cable on the wall. So that in this case, we have to use the adjustable hand tighten, hang anchor have to be utilized, and also lighting fixture need to be installed. So this is what how to utilize it for is you need to cut the sheet metal. So this is the sheet metal side, 2 meter, 1 meter. You have to cut the sheet metal to this shape and to form a cable tray and fix on the wall. So what you have to do is you have to start drawing, provide a drawing how to form the appropriate cable tray system. We have to watch the process, how to cut the sheet metal and how to dry, and also we have to estimate the sheet metal materials and the number, and we have to work the process, how to fix on the wall. So you only have to you have to do it. This is what the typical of the process. The next one is we are talking about the adhesive and the tape. In this case, before we are using the adhesive and tape, we have to assess a load limit. Load limit need to be assessed. Suitable accessories that can be fixed with the adhesive and the tape. In this case, we also have to be aware of the hazard and safety. Hazard and safety to use a chemical fixing device because the adhesives are the chemical devices. We have to follow the chemical safety system. So in this case, fume or cutting, eye, and also the eye protection need to be well, and the physical contact, also hand protection need to be aware of. So we also have to follow the appropriate technique for fixing the adhesive and tape. Tapes are the common use in the home. They are not suitable to fix the heavy item to the surface. Due to the stress, item will be straightened from the surface. The suitable place are we have to utilize the label and the nameplate to the swivel fixing, or we can utilize PVC dart with a double-sided tape or the rear side. So they are suitable place to use a tape. So this is for the kind of the adhesive. So that the size of the dart should be small size and only have one or two cable. So in this case, we can utilize the adhesive tape. Inside, as the weight on the cable over time can cause the tape to give way and the dust to pass from the surface. So this is for the type of the adhesive tape. So these are double-sided tape. They use for the lightweight surface. So we use the round type. We cause the tape to let go from the surface. And hook and the loose type they use to screw out the position where they need to be relocate often and quickly. And this is for a patch load and communication panel. We can utilize the load tape. In this case, we also utilize the glue and the solvent. In this case, PVC conduit cement are the kind of the glue and solvent. The function is to join the conjugate together and prevent them from splitting. So this is a prevent the ingress of the unwanted item. So water and dust that can be damaged again. So therefore, when we are joining the conjugate, we have to use a conjugate. By using the conjugate, it can prevent the water and the dust to come into the conjugate. Also, we also can maintain the integrity of the electrical system, insulation and the protection from the mechanical damage. Associated in which can be faced using the adhesive and tapes are the double-sided tape. They usually only on the items which are the lightweight, especially the label, small PVC conduit, and the set adhesive cable. And the PVC conduits you have to use with the PVC cement. At the time when the PVC conduit are installed, it is requirement that all joints are the screws as not to spray and the H4 cable so the PVC cement used on the joint to fit them together. So this is what they are facing. The PVC cement is a solvent chemical. When the contact is made with the anchor and the air is need to be removed and the bond made that is a chemical mixed between two the surface. So the technical surface must be clean. Before you are using the antis adhesive, we have to clean the surface. No paint, no dust, and no loose material, no oil, and no residue. We have to use a latest stronger solvent cement have to be utilized. So this is they are the place of PVC cement to put after that we can put the PVC conduit. Solvent cement must be applied to the one surface and completely around the circumference of the conduit. Two plates of the conduits are pushed together and held in the position until the conduit dry cement to be set in the 2 seconds. So this is the way how to utilize a PVC conduit. So in this case, we also have to worry about the chemical hazard. So that we have to wear the personal protective equipment must be utilized, and the chemicals can enter to the body. Chemical can enter to the body by inhalation. So that in this case, air fumes and lead the chemical mix with the air and can enter to the body through the lung and direct to the bloodstream. And also the injection chemical, when you are using chemical by hand and you either put your hand, so the chemical can go into your mouth. Absorption of skin cut is the absorption through the skin is due to the contact if the skin is broken due to cut or it gets the chemical it directly pass to the blood supply. So before handling the any chemical, in this case, we have to refer the MSC. MSC is the material safety data sheet must be utilized. So on the material safety data sheet is explained about the kind of chemical and the appropriate handling method, appropriate first aid methods are also written on the chemical safety data sheet. So that the material safety data sheet must be referred and use appropriate glove and the noise protection, apron and the eye protection must be worn. So in this case, we have to see that tutorial. We have to draw the stop wall to top plate and noggin and the stop brace, bottom plate and a plaster bolt. So this is for the question one. This is for the here is the stop wall. This is plaster bolt, square bottom plate and the flat holder. And question two is what is the stinges of plaster bolt anchor? Plaster bolt anchor here. There's a hollow wall anchor stinges of plaster bolt anchor. Question three is what type of thread fasten should be used for the plaster bolt? In this case, we have to utilize set drainage screw must be utilized. And also what two devices can be used to mount the switch plate to the plaster bolt? The answer is this is the plaster clip, bracket, and the screw must be utilized. So this is for the electrical trade 2A. We are talking about the how to fix the material, auto adhesive and tape. This is for the electrical trade. And then you also have to talking about the advanced diploma. Advanced diploma is last week we explained about the physics. Now we are looking at the advanced diploma. So last week we have talked about the engineering physics. So up to the lesson 11. So now we're talking about the lesson 12, Barnett expansion.
Barnett expansion. Barnett expansion can be calculated by the equation. Linear expansion is theta is equal to L alpha delta T is the original length. Theta is a linear expansion. Alpha is linear expansion. Theta is a change of the temperature. Also the volume expansion. Theta be equal to V beta delta T. So V is the original volume. Beta is the coefficient of the volumetric expansion. In this case, beta is equal to 3 alpha. Area expansion, delta is equal to A into gamma into delta T. So A is the original area, delta is the change in the area, and gamma is the area expansion coefficient. So gamma equal to 2 alpha. So this problem, on the hot day of the lovely gas, and 5 tanker look at 37,000 liters of the diesel fuel. It encounters cool weather in the filter where the temperature was 23 degrees Kelvin lower than the luxury gas. How many liters this is a deliver? The volumetric expansion for the diesel fuel is a 9.5 10 power grade. Coefficient of the linear expansion is equal to 11 10 power minus 6 grade. So we have to use like in this case the delta B is going to be beta and delta T. The original volume is 37,000 liter. Beta is 9.4 into 10 power minus 9.5 into 10 power minus 4. Delta T is minus 23. So equal to minus 808 liter. Original is 37,000. The liter difference is minus 808. So that you add this two equal to 36190 liter. When the delivery, so this is the volume with both are smaller because of the expansion. So this is a negative expansion because of the cooler temperature. And another the temperature and heat. Heat is the energy transfer between the system and its environment. Because of the temperature difference, that is the between them. So the 1 calorie heat is going to be 3.968 10 power minus 3 BTU or 4.1878 joules. The heat absorption and heat capacity can also be calculated. Q is going to C into delta T or C into dF minus Ti. Or the C equal to M into C. This is T is the final temperature, Ti is the initial temperature. In this case, small c is equal to the space-based heat capacity. So 4190 joule by kilogram Kelvin. Mass is M is equal to mass. So in this case, Q can go into the plate, MC into delta T. So MC into dF minus Ti. Molar superstation can also be calculated. 1 mole is equal to the 6.02 to 10 power 23 elementary units. So key of the transformation. So the solid 0 D is going to liquid 0 D, so the changing liquid to the liquid of temperature change and the liquid to the vapor change. So the amount that heat required for the change the state, solid to liquid change, this is the latent heat. The heat required to change the solid to liquid is the latent heat can be calculated. So this problem, how much heat must be absorbed by the ice on mass, 720 grams at the minus 10 degrees, take the liquid state at the liquid degree. So there are 3 things. Minus 10 degrees centigrade ice is changing there, 0 degrees centigrade ice. In this case, the temperature change. Temperature change can be calculated MC and MR mass of the ice, for the heat specific of the ice and the heat. Change of the temperature can be calculated and then ice to water change. This is a change in the state. Change the state of 0 degrees centigrade ice to 0 degrees centigrade water change. So in this case, I want to multiply the latent heat. To do is to ice multiply the latent heat. And 3, change of the temperature. So in this case, T3 is equal to the water mass multiply water coefficient multiply delta T. This is equal to 1 plus 2 plus 3. So the M ice delta T plus M ice is plus M water C water is delta T. Then we just substitute. So the M ice is 720 by 1000 kilograms. I is 1 to 2 kilogram, delta T is 0 minus 10. Plus MI is 720 by 1000, delta T is 333 kilogram Kelvin. Plus water passing 720 by 1000, water passing is 4192 kilogram Kelvin, water temperature is 15 minus 0. So we got the two that is 300 kilojoule. Another one is a copper slab input mass and is 25 grams. It's a heated in the laboratory proven to a temperature T of 320 degrees. The slab is a 10 droplets into the glass jar containing N2 220 grams of water. The heat capacity of the beaker is 145 kilograms per Kelvin. Initial temperature of the water and the beaker is at 20 degrees. Find the temperature. Assume the water does not rise. This means the sludge is over here. Sludge over heated and then put in the beaker. So then we get the water heat absorbed by the sludge and the water. This is so the sludge temperature and the beaker sludge heat. Beaker heat and water heat all combination is 0. In this case, I distribute the water heat and the CDU and the TF minus TI. Beaker heat is QV, CDU and TF minus TI. And this is the copper heat. So this is the CC and TF minus TI. So therefore, the final temperature can also be calculated. CC and T plus CDU.
有时也送票件妈讲我没有说他妈的我们现在刚好你们的面送票件妈的的，后面去刷不一样，今天上面压力了，还没不管嘞。
So the CC is a 0.093 and is a mass of the combined 75, temperature is 312. And then also the beaker might is 45, the temperature is 12. And also the copper water might is 1, water temperature is 220, CDU is 1, and 220, and temperature is 12. So the is 0.093 and is 75.
我们今天过到的 NG， 因为过来的干嘛的？
Finally, what you call is final temperature.
因为问题上的，我不知道快点，你别干，带那别干。
对哦，
他说拿不来问题，你别干，这面变成啥了？马路上马车被讲了，慢慢的。
你们笑了。Now we're talking about the gas lesson.
For the gas pressure multiplied volume is mass multiplied R multiplied T. This is for the B is the pressure, B is the volume, I is the gas constant, T is the temperature. K is the Boltzmann constant can also be calculated, so this is the R divided by N. A1 to 10 divided by molecules Kelvin divided by 6.0 to 10 power 23. So the 1 by 3 is 10 power minus 3, 23 kilowatts Kelvin. So MI is PV is equal to NKT. What done by the gas and the constant temperature can also be calculated. So the initial volume to the final volume changing. So the water is equal to MRT and MPF minus KI. Okay, this problem is cylinder contains 12 liters of the oxygen at 20 degrees centigrade and 15 ADM. The temperature is raised to 35 degrees centigrade and the volume is reduced to 8.5 liters. What is the final pressure of the gas in the atmosphere? So we write down the equation PV equal to MRT. So the PV by D is to M bar, MI is a constant. P1 by P1 equal to P2 by P2. So initial pressure P1 is 12, the volume P1 is 12 liter. 12 liter here, initial pressure is 15. And also the initial temperature 20 degrees centigrade, so 20 plus 2 73. We have to find the final temperature. The final temperature has to be 5, and also the final volume is 8.5 liter. And for the here we can see that the final temperature T2 is 35 degrees centigrade, 35 plus 273. So in this case we only know that
倒反 plus 1是吧？那我的倒反 plus 1我理解了。
Here is P1 is 3, but we can calculate the P2, P1, P1 by T2, P1 equal to P2, P2 by the T2. This is the way we can calculate it. Okay, analysis problem. One mole of the oxygen is fed at the constant temperature T of 310 Kelvin from the initial volume Pi of the 12 liter to the final volume of 19 liter. Find the work done. This is the constant pressure expansion. The constant pressure expansion, water can be calculated MRT and MPa by Pi. One mole is one mole, I is 8.31. And also there's a temperature T, 310 Kelvin substitute. Initial final volume is at 19 liter here, initial volume 12 liter here. So by calculating this, you got the 1180 joule. This problem, the molar mass M of the oxygen is a 0.320 kilogram per mole. A, what is the average speed at the 300 Kelvin? B, room mean square speed at the 300 Kelvin. C, Robert's speed at the 300 Kelvin. So the average speed can be calculated square root of 8 RT by M. 8, I is 8.31, temperature 300, I is 3.1416, mass is 0.032. You got the 445 meters per second. Okay, so room mean square speed. 3 is square root of 3 RT by M. 3 multiplied R is 8.31, temperature is 300 Kelvin, mass is 1.032. You got the 483 meters per second. That Robert speed. VB is square root of 2 RT by M. Square root of 2, I is 8.31, D is 300 Kelvin, mass is 0.332, so you got 395 meters per second.
အမှန်ပဲလေအကားကြီးကိုလှုပ်ရှားနေတာ
Now we're talking about the another gas of program.
Based on the heat transfer weight, you understand this topic 10 heat transfer weight, study the slide 1 to 6, do the exercise questions are 29 to question 31.
ပြီးသွားပြီဖြစ်သွားပြီ
Now we're talking about the heat temperature weight.
Molar specific heat at the constant volume. The initial state of the gas is a heated final state. In this case, we can write the equation. T is a Q equal to mCV delta T. So this is the change in the internal energy. When you are giving the heat to the gas, the internal energy can be changing. So the change in internal energy is delta EINT. This is the mCV delta T minus W. In this case, the delta EINT is a change in internal energy, and it's a number of the molecule. CV is the calorific value of the gas, and delta T is the change in temperature to use the water. Therefore, from these equations when the W is 0, in this case, the delta EINT is mCV delta T, where CV is the delta EINT by N delta T. This is the calorific value can be calculated. Change in the energy divided by number of the gas molecule divided by change in the temperature. Change entropy. When we are providing a heat to the gas, inside that their internal energy will also be changing. So this is the change in entropy. Delta A is the final entropy by the initial entropy. All the heat can integrate from initial state to final state and Q by D. So heat losses is a equation is the delta Sk is equal to minus G by D. Pk is the delta Sk is equal to plus G by D. The force due to the entropy can also be calculated. The dE is equal to dQ minus dW. Now based on the Stalin engine. Stalin engine is here. So first these are the gas that is compressed to the C to D. Okay, compressed. The following is a smaller. From initial volume is a BB and final volume becomes a BA. So BB greater than BB. So BB greater than BA. So in this case, when the gas is compressed to the BB, so heat QA is dissipated. And and then the heat get as a D2A.
စိတ်လုံးတော့ရ
From
တာ
the D2A that we provide the heat to the gas, temperature will be risen from the TF, the TH,
ဟောနှစ်ခုတော့ရတာ
so the
ဘုံဘုံ
heat
စီ
is
မှာမိမစိတ်လုံးတော့တော့ရတာ
expansion.
ဟုတ်လား
တော့ပါတော့မှနှစ်လုံးရတာဘယ်တော့ဆိုတော့ငါနားမကြည့်တော့မှစိတ်လုံးတော့နဲ့
အေးပေါ့
မဲဒီမှာဒီတော့ငါခဏခဏ
You see that heat
ဟို
is
က
rated.
မချက်တွေပြီးလို့
And heat that DA is there. Is rated. So the temperature decrease from the DH to DL. This is the operation of the Starling engine. C2D compress, and then D2A has all the heat, and A to B expand, and final B2C there's cooling. So the heat will be dissolved. This is the working cycle of the Starling engine.
ဟောဘလို့ဆောင်မို့ပေါ်နေရဖြစ်တယ်
Carnot cycle.
ဟုတ်လား
Problem. Three Carnot engines are operated between the
Yo,
charge
yeah.
of the is a 400 Kelvin, 500 Kelvin, these are 300 Kelvin, and 800 Kelvin, these are 400 Kelvin, and 300 Kelvin. Branded are engines across the world, they are the thermal efficiency.
ဟိုကဖြစ်တာပေါ့
Efficiency can be calculated 1 minus PA by DH. This means that 1 minus low temperature by high temperature. The four in case are the 400, 500, so that the 1 minus 400 by 500, because that are 20%. Is a 1 minus 300 by 800 or 25%. 1 minus 400 by 300, so 34%. So we ran the engine, so that's the highest efficiency.
ဟိုကသူဘက်ကဟာရော
The B is the middle and the A is the lower. So this is CPA. Okay, the next problem. Imagine the Carnot engine that operates between the temperature TH at 850 Kelvin and TS at 350 Kelvin. Engine power force at 1,200 joule of the wall. Cycle which takes the 0.25 seconds.
ဟာဘာဒီပဲ
A, what is the efficiency of the engine? B, what is the average power P of the engine? C, how much energy is extracted as heat from the high temperature reservoir every cycle? D, how much energy is delivered as heat to the low temperature reservoir every cycle? E, by how much does the entropy of the working substance change as a result of the energy transfer to it from the high temperature reservoir from it to low temperature reservoir? First these are the Carnot engine here, high temperature and the low temperature are given. Therefore, the first you have to calculate the efficiency. Efficiency is minus D, 1 minus dA by dH. So that is a high temperature is 850 and low temperature is PI given at 300 Kelvin.
ဒီလိုမှတော့မပြီးဘူးအဲ
5%.
ညဘက်ကနေစပြီးညနေဝါတုံကိုစီမံလုပ်တာလေငါတော့မှပြီးပြီညပိုင်းမှာလာနေတာညပိုင်းကနေညနေဝါမြုံကိုစီစဉ်နေအောက်မလေးတော့
And time is at 0.25. So the Q by T, so the Q is at 1,200 joule. T is at 0.25 seconds. So you got a 4,800 watt or 4.8 kilowatt. And C, how much energy QH? QH is at Q by E. So this is for the output water. Output water is at 4.8 kilowatt. Output water heat is already given at 1,200 joule. Divided by efficiency. So we can get the inputs heat. So the 1,200 joule divided by 0.652, you got the 1,855 joule. And T, this is the QL. QL is equal to QH minus W. QA is we already know the 1,855. And also the output water is already given the 1,200 joule, so you got the 355 joule. And then we also calculate the SH. SH means the so this is for the entropy change. Entropy change has been calculated data SH to QH by DH. QA is already given here. QA is 1,855. Okay? High temperature DH divided by 850, so you got a 2.18 joule per Kelvin. Data SA, QA by DL. QA by DL, QA is we already know 655 here. DL, low temperature DL is already given at 300 Kelvin, so divided by minus 2.18 joule per Kelvin. So the negative transfer, data S, data SA plus data SA, 2.18 plus minus 2.18, so you got it.
ဘုံဘုံကပို့ဆိုတာ
Based on the heat transfer and weight theory and the problem, you stay to the slide 1 to 6, do the exercise question 29 to question 31.
Now we're talking about the harmonic motion. Harmonic motion lesson 15.
Harmonic and the motion and the wave. So when the spring compress or elongate, so that it will slow the energy. So spring here, so this is the initial there is air, so we extend it together air. In this case, the case is spring constant and it's a mass. Angular velocity can be calculated omega is equal to square root of k by m. So it's the case that spring constant and it's a mass. The frequency also can calculate if it's a omega by 2 bar. Period is a 1 by m. So this is for the spring calculation. With this problem, the blouse full mass m is at 380 grams. It fastened to a spring, full spring constant. It is a 35 Newton per meter. The block is a pull in the distance 8 to 11 centimeter from its equilibrium position at the h equal to 0 on the frictionless surface and the release from the rest at the t equal to 0. A. What are the angular frequency, the frequency and the period of the resultant motion? B. What is the amplitude of the oscillation? C. What is the maximum speed Vm of the oscillating blouse and when is the blouse when it has this period? D. What is the magnitude of the acceleration? E. What is the phase constant phi for this motion? F. What is the displacement function? So the first thing you have to calculate is omega here. This is the angular frequency. Angular frequency equation is square root of k by m. In this case, there's a k, the spring constant. The spring constant is given. The spring constant is 35 Newton per meter. So you substitute here. And then the spring is a mass, 380 grams. CAD divided by change the kilogram divided by 1000, so that's 0.38. So you got the 9.176 radian per second. This is for the omega. And then based on the omega, that we have to utilize the frequency. The frequency F is going to be omega by 2 pi. So the 9.76 divided by 2 into 3.1410, you got the 1 by 6 halves. And also there's a die. Die is going to 1 by frequency, 1 divided by 1 by 6, so the 0 by 6 second or 340 seconds. And the P, what is the amplitude of oscillation? 8m is 11 cm because here is given. The block is at the distance is 11 cm. Amplitude is the maximum distance is the elongation at 11 cm. C, what is the maximum speed on the oscillating block? Where is the block when it's PM can be calculated, omega and HM. If a 11 centimeter, so change to the meter divided by 100, omega we already know is 9.7. So we substitute for the 1 by 1 meter per second. And T, what is the magnitude of the acceleration? Acceleration magnitude is the AM, is the omega squared to HM. So omega we already know is 9.7 squared, and the HM is 11 centimeter divided by meter divided by 100. Meter per second squared. E. What is the phase constant phi for the motion? So the H is equal to T equal to 0. In this case, phi is equal to H at HM. Cos phi H by HM. So this is a 1 by 1 equal to 0. F. What is the displacement function? Displacement function H is HM cos omega d by plus phi. So in this case, H is HM already know. This is for the 11 centimeter, so 0.11 meter. And cos omega we already know that 9.78 and the angle phi is the angle 0. So we got the HD 0.11 cos 9.78 t. This is for the calculation. And also another problem. At the t equal to 0, the displacement h0 of the block is minus 8.5 centimeter. The block velocity v0 is 0.92 meter per second, and its acceleration a0 is 47 meter per second squared. A, what is the angular velocity of the system? B, what are the phase constant phi and the amplitude hm? So firstly we calculate. So we write down the equation a0 is equal to hm cos phi is the equation 1. V0 is minus omega hm by equation 2. A0 is minus omega squared hm cos phi. This is the equation 3. So in this case, equation 1 divided by 3. A0 by hm cos phi by minus omega squared hm cos phi. So in this case, omega square is square root minus a0 by a0. So therefore, the omega is square root of a0 by a0.
A0
Equation 2 is divided by 1. Equation 2 is here.
Equation 1
divided by here. B0 by A0 is equal to minus
Hey, well, hey, yeah,
divided
well,
by
well,
divided by
well.
h and cos phi.
So down.
So this h and cancel sin phi by cos phi is tan phi minus omega tan phi. Tangent phi is equal to minus B0 by omega A0. Minus initial velocity B0 is already given the minus 0.92 meter per second. And initials are elongation A0 is minus 8.5 centimeters. So we substitute. So we got the minus 0.401. Phi is equal to tangent inverse minus 0.401. So you got the minus 25 or 155 degrees. And therefore the HM is A0 by cos phi. Phi is a minus 25, so then we substitute this equation. Minus 0.085 divided by cos minus 25, so you got the minus 0.94 meter. And phi 1 by 5. HM is equal to 0.085 divided by cos 1 by 5. So you got the 0.094 or 9 by 4 centimeter. So this is what is subplane calculation. So that when the subplane is compressed, it also retains the energy. The energy is simple harmonic motion. So energy is a UT is equal to half into Ka square. Is equal to half into KHM square, cos square omega d plus phi. And then simple harmonic motion equation is the mdA square by dt square plus bdA by dt plus kh is equal to 0. In this case, h is equal to hm e power minus bd by 2m cos omega z e plus phi. So this is the omega z is the oscillation frequency. Can be calculated the square root of k by n minus b square by 4 by O square. So this is supreme. Supreme is the mass. So oscillation can be calculated. Oscillation is the hm e power minus bd by 2n. This is the hm e power minus bd by 2n. So bd is an energy function half into khm square e power bd by minus bd by m. This is for the energy function of the supreme. Supreme called the simple harmonic motion. So this is the energy function of the simple harmonic motion.
So those lectures are that we're talking about the lesson 12, 13, 14, and 15. So those are you can get from the design. So engineering physics. So you read the page 58 to 86, and then all the written lesson, all the those videos you can see on the design. So highlightcomputer.com/video lesson.pdf. By downloading this link, you can see the written notes for those lessons. So this is for the lesson 12 to 15, and also we see the lesson 16.
The speed of the transfer weight, the transverse weights are can be calculated. K is equal to omega d. This is constant. V is the linear velocity, so omega by k. K is a constant. So this is the lambda by d or the lambda f. So this problem is in this case lambda is the wavelength, f is the frequency, d is the time. Omega is the angular frequency, t is the constant, weight constant. V is the linear velocity. So in this problem, a weight traveling along a string is described by the YHD is equal to the 0.0037 size 71.18 minus 2.72 t. A, what is the amplitude of this wave? B, what are the wavelength, period, and the frequency of this wave? C, what is the velocity of this wave? D, what is the displacement y at the h equal to 22.5 centimeter, and D is 80.9 seconds. Okay, firstly we have to calculate the amplitude. Amplitude is this one is the maximum amplitude, HM 0.00327 meter. So multiply with 1 1000, you got a 3 by 27 millimeter. B, YH is a 0.003275 times 2 by YH minus 2 by 72 D. So YH is a 0.00327 times 72 by YH minus 2 by 72 D. So we compare with the equation, YH is equal to YM psi KH minus omega D. So in this case, the YM is 0.00327, K is 72 by 1, omega is 2 by 72. So K is 72 by 1 radian per meter, omega is 2 by 72 radian per second. So the lambda wavelength can also be calculated 2 by K. So that this is 2 by 3 by 1.16, K is 72 by 1. So you got a 0.0871 meter, multiply with 1000, you got a 8.71 millimeter. 8.71 millimeter. 8.71 millimeter.
Hey.
Okay, another one we also need to calculate the period D. D is equal to 2 by omega. So that's 2 into 3 by 1.16 divided by 2 by 72. So you got a 2 by 31 second. And frequency F is equal to 1 by D. We already know D is 2 by 31 second. So 1 by 2 by 31, so that's 0 by 433 half. And velocity V is omega by K. Omega I already know is, the omega is we know that 2 by 72, and K is 72 by 1. So 0 by 0, 37 seconds.
Okay.
Okay, based on the topic stands the heat transfer and the wave. To start off with the harmonic motion and waves, you have to do the follow-up study. So the slide 7 to 12 and do the exercises, question 32 to question 35.
And now we're talking about the weight and sound.
Wait, this is all the electric waves equation. Wave equation usually we write down the equations are YHD is equal to YN psi KH minus omega D. So A is a horizontal distance, is a die. In this case, vertical is amplitude is a YN, K is a constant of the wave, omega is the angular frequency, and A is the horizontal moment, and D is the die. So this is the waves of Y that we calculate. YHD is equal to the amplitude of the wave, and the anti-die is equal to the maximum amplitude multiplied with the wave constant K, and the horizontal travel distance H, and angular velocity is omega, and the die D. So based on this equation that we solved this problem, X 19.9 seconds, the transfer displacement Y on the element of the string, and the A is equal to 0.215 meter is 1.92 millimeter. So in this case, the Y is equal to the 1.92, and H is 0.255. So A the what is the K? So we have to calculate that K value, and Y we have to calculate U. U is the velocity. Velocity of the wave, the transmission velocity of the string element on the string, and the die. P, what is the transfer acceleration AY on the string element and the die. So we write down the wave equation, YH is equal to YM psi KH minus omega D. So this is all the velocities can be calculated. The differentiate the displacement. Y is equal to Q is equal to dy by dt. So that the differentiate dy by dt YM psi KH minus omega D. So we differentiate, what you call is a Ym minus cos Kh minus omega D multiply omega. So you is going to find out Ym omega cos Kh minus omega D. This is called the velocity equation. In the meantime, the acceleration is also the differentiate again is velocity. So the d by dt minus omega cos Kh minus omega D. So the differentiation is equation. What you got is this one is the cos differentiation you got the minus. Okay, so this one is you differentiate U is going to dy dt, so d by dt yn psi k minus omega d. So what you call is U is going to yn omega cos k minus omega d. Ay is going to u by dt. D by dt, so this is what is yn omega cos kh minus omega t. So what you call is minus omega square y and sine kh minus omega t. So this is for the velocity equation. This is the acceleration equation. Then we substitute the numerical value. So the omega is 2/7 meters radian per second. K is 72/1. And y is 1/92. K is 2/2/5. So those you substitute. Q is equal to the minus 1/92. 1/92 into the 2/7 cos 72/1 multiply 255 minus 72/1 t. This is the equation for this wave velocity equation. Okay, so the next one is the energy and power of the wave traveling around the string. So when the wave is traveling around the string, it also possesses the energy and the power. They possess the kinetic energy, elastic potential energy, and the energies are transport. So the rate of the energy transmission can be calculated. Pk is equal to half into P and P squared. Pk is the rate of the change, and this is the distance. This is for the differentiation. This is the mass multiplied with the velocity squared. Therefore, the dk by dt average is equal to 1/k u v omega squared u v m squared. U is the weight constant, and this is v is the velocity, linear velocity, angular velocity, and the massive mass weight length. So the average is equal to 2 into dk by dt average. The average is half into u v omega squared and yn squared. Yn is the particle distance and u is the weight length. Okay, so that's all that we saw in this problem. Sound wave is defined roughly as any longitudinal wave. Wave can be the longitudinal wave. So wave traveling this one, the wave oscillating this way, this is longitudinal wave. Wave traveling this one, moving up and down, this is the particle sound. Transfer wave. So the sound wave is defined roughly as any longitudinal wave. Wave traveling this way, so this one rotating, so the oscillation, the longitudinal wave. When wave traveling like this, wave is the oscillation of particularly, so that way the transfer wave. Sound wave is defined roughly as any longitudinal wave. Longitudinal wave is the oscillation whether the direction of the wave travel. So the wave travel this way, the parallel travel is the longitudinal wave, the perpendicular travel is the transfer wave. So we can calculate the speed of the transfer wave around the string. We can calculate the square root of r by u. The I is the square root of the elastic property divided by the inertial property. U is with the inertial property. And we also calculate the square root of beta by p by mu. In this case, p is the speed of the sound, p is the bar modulus. Bar modulus can also calculate the p equal to delta p by delta p by p. Delta p is the change of pressure, delta p by p is the specific volumetric change. This one is sound velocity is depending on the pressure of the medium, the sound medium, and the velocity change, and those things are affected on the sound velocity.
And the last one is a light and photon. Lesson 18.
This is the light photon equation. When the light is hit on the surface, the star of the light are reflected, star of the light are the end. This is the reflection, this is the reflection. So this is the angle beta 1 is the incident angle, beta 2 is the reflected angle reflection, and beta 3 is the angle reflection. Beta 1 is incident angle, beta 2 is the reflection angle, and beta 3 is reflection angle. So the star and this light end up from the median N1 to median N2. So the N1 side beta 1 is the N2 side beta 2. N1 and N2 are the density of the median. N1 side beta 1 is equal to N2 side beta 3. So this problem, the lights are just enter the materials at 2 and the point A, then reach the point B on the interface between the material 2 and material 3. So we have to calculate what is the angle of reflection and B, what is the angle of reflection. Angle of reflection into the air. So this is the my 4 here. This angle will be the 40 degree. This is 40 degree here. 40 degree, so theta 1 can be calculated 90 minus 40, so we call this up. So this is at a 50 degree. Angle 50 degree. So we can calculate theta 1. Theta 1 is a 90 minus 50, so we call this up 40 degree. So this theta A, y is a 1.7733, this is N2 1.77, and theta 3 is a M3 is a 1. So the theta y is the incident angle can be calculated. Incident angle is equal to this is a 90 minus a 50, we call this 40 degree. And one side theta y is equal to N2 sine theta 2. So y by 3 sine 40 is equal to 1.77 sine theta 2. So theta 2 can be calculated sine over 1 by 3 by 1.77 sine 40, we call it 29 degree. And then the problem, this is why you're moving from the median 2 to median 3. And 2 sine theta 2 is equal to N3 sine theta 3. So 1.77 sine 29 is equal to y into sine theta 3. Theta 3 can be calculated sine over 1.77 sine 29, so equal to 59 degree. This is for the light transmission. And the next one is the photon quantum of the light. The photon quantum of the light equation can be calculated. Frequency F is equal to C by lambda. F is the wave. Velocity of the light, C is the velocity of the light, F is the wave frequency, lambda is the wavelength. And E equals to H multiplied by F. E is the photon energy, H is the Planck constant, 6.63 10 power minus 34 per second, and this is called F. So this is F the frequency. So the photons are electric equation can be calculated. HF is equal to K maximum plus phi. In this case, K maximum is the maximum energy, and phi is the minimum energy required to emit the electron. This is the key. And also the energy required to store the electron is V store is equal to H by C multiplied F. In this case, H unit is 6.6 into the 10 power minus 34. This is for the Planck constant in the H. This is the equation for to calculate for the photon of the light. So in this problem, a sodium vapor leg is placed at the center of the large sphere that absorbs all the light reaching it. The rate at which the lamp emits the energy of 100 watts, assume that emission is entirely at the wavelength of the 590 nanometer, and at what rate the photons are absorbed by the sphere. The sodium vapor leg is placed at the center of the large sphere that absorbs all light reaching it. The rate at which the leg emits the energy 100 watts, assume that the emission is entirely at the wavelength of the 590 centimeter. At what rate are the photons absorbed by the sphere? So in this case, we have to calculate the rate of the absorption in the R emission. This is equal to the rate of the energy emission divided by energy bar emitted photon. So the rate of the energy emission is the emits divided by energy bar emitted photon is the HRF. So the image are F is equal to C by lambda. So H multiplied C by lambda. This is the numerator, and the numerator is the P image. So therefore, this lambda go to the numerator. So P image multiplied lambda by AC. So then we substitute the power emission is, and we calculate the 100 watts, and also the lambda. Lambda is the 590 into 10 power minus 9. So this is the wavelength. Wavelength is 590 millimeter, so 590 into 10 power minus 9. A is 6.6 into 10 power minus 34, and velocity of light C is 3 into 10 power 8. So by solving this one, we got 2.97 into 10 power 20 photon per second. Okay, this problem, the potential point is a distance I equal to 3 by 5 beta. For an isotropic light, so that emits the energy at the rate P is equal to 1 by 5 watt. The whole function phi of the potential is 2.2 electron volt. A, how long will it take for the phi to absorb the energy to eject the electron? The circular plus phi radius is the phi equal to 10 power minus 11 beta. P, find the work function phi of the sodium. So this sodium is the hit on the light hit on the sodium phi. So in this case, this is for the light is the hit on the sodium phi. So this is the 3 by 5 beta. So in this case, phi is equal to 3 by 5 to 10 power minus 19, and so the K is equal to that 7.85 to 10 power minus 21 beta square. And theta B can calculate it, theta E by the B absorption. Delta D also they can calculate pi by I into A. So the delta D is equal to pi. The emission pi is equal to this is for the emitted illumination. So the emitted power divided by 4 by R square and multiplied with A. Also this is the delta D 4 by R square pi the emitted divided by A. So the pi is equal to we can calculate emitted power be emitted by 4 by R square. So the emitted power can be calculated. So here will be 4 by R square 5 be emitted divided by A. So 4 by 3 by 1416. I is 3 by 5 square. And also there's a 5 by 5 to 10 power minus 19. Emitted power is 1 by 5. And also there's a this is A is 7 by 8 by 10 power minus 21. By solving this one, you got the D is 1 by 3 hour. 450 is second or 1 by 3 hour. This is the equation for the moment of the photon. So this is a beta is a photon moment. This is the H F by C. So this is H by lambda. So this is the moment on the photon. Here is the energy. So energy can be calculated as A squared divided by 8 ml squared into n squared. So A is a Planck constant. A is a mass. A is given as n lambda by 2. So this is for the A is a 1, 2, 3. This is for the circular path. For the electrons are moving around path. So this is the path number is n. And lambda is a wavelength. This A can be calculated. A is a Planck constant. And so the delta E, the change of the energy can be calculated as high energy minus low energy. So E high minus E low. Delta E is going to be HF, E high minus E low. This means that when there's the electron moving from the high energy to the low energy, but if produce a wave, the wave frequency is can be calculated by the HF. This program, an electron is confined to the one-dimensional infinitely gives a potential energy where all the hundreds of picometer. A, what is the smallest amount of the energy? B, how much energy must be transferred to electron? C, if the electron gains the energy for the jump from energy level E1 to E2 by absorbing the light by the wavelength. So first these are the energy is possessed. When the electrons are moving around the nucleus, they possess the energy. This energy can be calculated A squared divided by 8 ml squared into n squared. So in this case, L can be calculated by this equation n lambda by 2. And n is a 1, 2, 3, 4, 5, so lambda is a wavelength. A is a Planck constant. In this case, the ground state is N1 is ground state. The energy at the ground state can be calculated as E1. So in the place of the N, here you can calculate 1, so E1. 6 by 6 to 10 power minus 34 square minus 1 square. So this is for the ground state. And also the A. Mass of the electron is 9.11 to 10 power 11, 9.1 to 10 power 7. And L. This is for this and also calculated. So L equal to this n lambda by 2. So this equation that we substitute like this. In this case, this one is given as 100 to 10 power minus 12. So in this case, electron volt can also be calculated. Electron volt is E1 is we got the thing is 6.03 to 10 power minus 90 joules. In this case, then electron volt can calculate it. 1 electron volt is 1.6 to 10 power minus 19. So the E1 by 1.6 to 10 power minus 19. So you got the electron volt is 37.7 electron volt. This is for the ground state. And then the second is the second excited state. Second excited state is E is 31. E31 is a ground state 2. The state 2. State 2 is a E3. Ground state is a E1. So this is moving from the 1 to 3. So E31. So it's the 8 squared to 8 ml squared. 3 squared minus 1 squared. So that we substitute H is that we substitute here. H is equal to we got 700 10 power minus 34 square. You substitute. So M and F value you substitute. So you got a thing is 4133 and do 10 power minus 19 joule. So this is the way we can calculate the electrons energy.